Okay, class, in this lesson, we are going to learn to compute the cost of putting an ad for a used car. We're going to look at how to compute the cost of sales tax on cars. And then we're going to compute quartiles in interquartile range and help you to understand the use of those information. Okay, so let's go ahead and get started. So, how do buyers and sellers advertise for automobiles or cars? So, car ads online and in print media use a lot of abbreviations to communicate what's available in a car, and they do this to save space and therefore lower the cost of advertising this information. So, words such as mint and immaculate are used to describe cars that are in really good condition. And those are really good objectives because when you think of the word in mint condition or immaculate condition, you think about a car that is barely used, okay? A car with a lot of option is often listed as loaded. So they use the word loaded to communicate that there's a lot of extra things that are available in this car that may not be available in a standard version of that same car, okay? And then to express miles, it is often expressed in thousands, and they use the letter K to abbreviate thousands. Now, in this chart, there are a number of abbreviations, and this is not a comprehensive list, but it is some of those that are used in advertising to communicate what's available. So for example, ABS, we all probably know, stands for anti-lock braking system. BO means that the seller is looking for the best offer. Another acronym like GPS, we all know what that is. That means that the car has a navigation system. STD at the bottom stands for manual transmission. So that may be something that we may not be familiar with. Manual transmission is almost not available in cars today. I think there's probably a couple models today in 2025 where manual transmission is still available, but for the most part, cars generally have automatic transmission. Okay, so it's really important to know what these terms mean because then you'll be able to read through the ads a little bit faster and focus on the ones that you'd be interested in, okay? Okay, so let's take a look at example one here. Leilani purchased a used car for $7,400 and had to pay 8.5% sales tax. And the question here is, how much tax did she pay for this car? Well, to calculate this, we would, we would take $7,400, and we're going to multiply this by 8.5%, and we're going to need to convert this into a decimal, so that's going to be 0.085, and when we do, punch this in the calculator, we get $629, okay? So that is how much Leilani would pay in taxes. So this is on top of the price of the car. All right, now let's take a look at example two. The cost of an automobile ad is determined by its length, okay? So Juan plans to sell his car and places a 5-line ad in an auto enthusiast publication. The publication charges $31 for the first 2 lines and then $6 per extra line to run the ad for 1 week. So the question here is, what will Juan's ad costs run if he were to do this for 2 weeks? Okay. So Juan is placing a 5-line ad, okay? 5-line ad right here. And we know that the publication charges $31 for the first 2 lines, okay? So we know that Juan is going to incur a cost of $31. That's for the first 2 lines. And then there's a charge of $6 per extra line to run the ad for 1 week, okay? So if $31 is what's being charged for the first 2 lines, and he's running a 5-line ad, that means there will be 3 extra lines. So we're going to need to add the cost of 3 extra lines times $6, because it's $6 per line, and that is going to equal $31 plus $18, which works out to $49. And that's for 1 week. Okay, and we're told that Juan is going to run the ad for 2 weeks, so we need to double this amount. So $49 times 2 weeks is going to equal $98. Okay, so that is the total cost for a 5-line ad to run for 2 weeks. Okay, let's go ahead and move on. So the next section here is we're going to talk about how statistics can help you negotiate the sale or purchase of a car. Okay, so sources like our websites like Kelley Blue Book, which is kbb.com, and Edmunds.com are 2 popular and excellent sources on the internet to find the value of a used car. Okay, they give you a lot of information that a lot of consumers go to, whether they're buying a car or selling a car, to get some intelligence. So as you search, what you want to do is compile a list of advertised prices for the car or the cars that you want. Okay, and then you're going to use that information to help analyze the data that you've collected and compile that to determine what you should ultimately sell or buy the car for. Okay, the term measure of central tendency represents the quote-unquote typical values for the data. Okay, so it's important that we look for the measure of central tendency. You're going to find less variability, right? So fewer differences. Prices are going to be clustered around a general number for new cars, because all new cars are in the same condition. When we're talking about used cars, we have a lot more variability when it comes to the condition of the car, and therefore pricing will also show a lot of variability. So just be aware of that when you're purchasing a used car versus a new car. Okay, so one of the things that we're going to look at are quartiles. So if you want to find out more about how the information you've collected on a particular car is spread out or dispersed, you can use what's called quartiles. Okay, quartiles are essentially 4 values, and we represent them by quartile 1, quartile 2, 3, and 4. And that basically divides the distribution of the data into 4 subsets that each contain 25% of the data. Okay, so let's take a look at how we can use quartiles. So in this example, we're told to find the quartiles in the interquartile range, or IQR, for the tire pressures of car tires at America's Tires. Okay, so we're given 9 different values. We've got a tire pressure of 15 psi, 17 psi, 21 psi, and it goes all the way up to 34 psi. Now, as you will notice, the numbers are actually sorted or displayed in increasing order. When you are analyzing data in real life, data isn't necessarily sorted in ascending order. So one of the things that you're going to want to make sure that you do when you're looking at quartiles and interquartile range is to put those numbers in order. Okay, and I know I use the acronym PSI, but just be aware that tire pressures are measured in the United States in PSI, and that stands for pounds per square inch. Okay, All right, so the first thing we're going to do is, and I kind of mentioned this already, but the first thing you want to do is to count the number of numbers that we have, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Since this is already sorted in ascending order, we want to find the middle term. Since there are 9 terms in here, the middle term is going to be the 5th one. So 1, 2, 3, 4, 5. 31 is our middle term, and 31 ends up becoming our Q2. Okay, that's our second quartile. All right, so then what you're going to do to find the first quartile is count the number of numbers before the second quartile. In this case, we have 1, 2, 3, 4, and find the middle term. Well, we have an even number of numbers, and so the middle term is going to be between 17 and 21. Okay, well, and how do we find Q1? We're going to take 17 and 21, we're going to add them together, and we're going to divide that by 2. That works out to 38 over 2, or 19. So 19 is our first quartile. Okay, so I'm going to say that this is 19 here, and our first quartile sits right there. Okay, and then we're going to do the same thing for the third quartile. The third quartile are the numbers above quartile 2, so that would be 32, 32, 32, 34. There are 4 terms, and so we're going to find the middle term, which is in between here, and we don't really need to add these together because the average of 32 and 32 is 32. So we would say that our quartile 3 is 32. And then quartile 4 is the easiest one. That is the last number in this series. And so that's quartile 4. Okay? So that's how you find quartiles 1, 2, 3, and 4. And then to find the interquartile range, IQR, that is equal to quartile 3 minus quartile 1. Okay? Well, we know quartile 3 is 32, and quartile 1 is 19, and that works out to 13. So our interquartile range is 13. So what does the interquartile range tell us? Well, the interquartile range gives the range of the middle 50% of the data, right? And so if you have a small interquartile range, it means that the middle 50% of the numbers are clustered together, whereas a larger interquartile range means that the middle 50% of the numbers are more spread out. And so we calculate the IQR to help us to determine, is the middle 50% close together, right? Because the closer together they are, the tighter the number is and the more accurate the number will be when we talk about buying or selling a used car. Okay, so in this case, we're talking about tire pressure, and we have an interquartile range of 13, which means that it's spread out pretty far. There's a lot of variability in the middle 50% of the data that we're looking at. If the interquartile range were like 2 or 3, then we would say that the middle 50% are very close together, and therefore the tire pressures are very consistent. Okay, so when we're talking about selling, going back to selling cars or buying cars, if the numbers are very close together, then you have a higher confidence that the middle 50% is telling you that this price is truly the price that it should be. But if you have a larger spread, then your confidence is not as high, and then you have more variability in the pricing. And so there's a little bit more work that needs to be done. Okay. Anyway, I hope that made sense to you. If any of this was confusing, please go back to the beginning of the video and listen to it again. Thank you.